Are all welcome to class. I'm happy to know you are still with us and we are glad to have you on board. Thank you very much and welcome back to class. Today, in our chemistry class, we are going to take gas law. We are taking gas law. And without taking much of our time, as you can see on the board that the gas law were created in the early 17th century. The gas law was created in the 17th century and they were created to help scientists in finding the volume, amount, pressure and temperature when it comes to the matter of gas. Scientists discovered that at times gas have pressure, gas could have volume. And in order to handle the problem of calculating the amount, the pressure and the volume of gas. So in the 17th century, some scientists come together and put and created or invent some laws. They invent or create some laws which we call gas law. So this gas law are created or they are formulated or they are founded primarily to find solution to the problem that can arise as a result of the volume, the amount, the pressure and the temperature of gases. And that is why we come across gas law. I hope you understand that. Once I said gas law were created in the 17th century by some scientists so as to handle issues and problems that can arise as a result of the pressure, as a result of the volume, as a result of the temperature, and as a result of the amount of gas. So when we have issues that relate with gases, issues that can arise such as temperature, pressure and volume, then the amount of these gases were handled by what? By this gas law. Now we say there are three fundamental gas laws and they help to discover the relationship between pressure, temperature, volume and amount of gas. Look at it. There are three fundamental gas laws. These three are fundamental gas law which are Boyle's law, Charles law and Avogadro's law are to determine the relationship that exists between temperature, volume and pressure. They are to determine the relationship that exists between temperature, volume and pressure. So let us quickly go through these three gas laws. Number one is the Boyle's law. Now Boyle's law was discovered by Robert Boyles. Boyle's law was discovered by Robert Boyles in the year 1962. Boyle's law was discovered by Robert Boyles in the year 1662. And why was this Boyle's law discovered and what is its purpose? Its purpose is just to discover the correlation between pressure P and volume, assuming that temperature and amount of gas N remain constant. So what are we saying is that Boyle's law is primarily to determine the relationship or the correlation that exists between pressure P and volume V if temperature and amount of gas remain constant. Let us note that it is important to note that if temperature and pressure are constant, to determine the correlation between pressure and volume, then we use Boyle's law. Boyle's law, as I said once again, is discovered by Robert Boyles in 1962 to find the correlation between pressure and volume, provided that temperature and the amount of gas remain constant. If the amount of the gas remain constant and temperature remain constant, then to finding the relationship or the correlation that exists between pressure and volume, we are to use Boyle's law. Now, without, let's quickly see the law. What does Boyle's law says? Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided that temperature remain constant. I've explained the other time. But now this is the law. The law states that, Boyle's law states that the pressure of a given mass of gas is inversely proportional to the volume. The pressure of a gas is inversely proportional to the volume, provided that what? Temperature remain constant. That's very, very important. Please note that law. It's very, very important that you had that temperature is constant. Now let me repeat it again. The law, Boyle's law, states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided that the temperature remain constant. If and only if the temperature remain constant, then we can now say that the pressure of a fixed mass of gas is inversely proportional to the volume. I hope you understand what I'm trying to explain now. That is Boyle's law. Now we can mathematically denote Boyle's law as P. This is a variation sign inverse as 1. Now let's see. This is the discovery mathematically. Of course, we all know that this variation sign will become equal to, and when you introduce equal to, you introduce a constant k. Your constant can be c, it can be m, it can be any alphabet, but we choose to use k. So we introduce constant k. So now k times 1 over v. Now by the time you use k times 1, we give you k over v. Of course, you know this is equally over 1. So k times 1 is k, 1 times v is v. So the next thing is we cross multiply. By the time we cross multiply, 1 will multiply k, then p will multiply v. So you have k equal to pv. So from here now you can generate your equation or your formula. Now you have it to be p1 v1 will equal to p2 v2. So this is the mathematical expression of Boyle's law. v1 p1 is equal to p2 v2. So if you are asked to express mathematically Boyle's law, this is what you have to do. This is the mathematical expression of Boyle's law. I hope you understand that. If you don't understand, please get back to us with our on our WhatsApp number. On our WhatsApp number, you can reach us on our WhatsApp. He said you can reach us with 09066046776. You can reach us on this WhatsApp number. We will be there to provide answers and response to any of the difficulties that you are facing in course of understanding any of our online tutorial. So back to our Boyle's law. This is the Boyle's law mathematical representation. This is the graphical representation of Boyle's law. Now when you see this graph, this is pressure as this is volume as this. And when you see now, from the first graph now, you can see that from the first graph, now, if P increase, V will decrease, and vice versa. Why? Because we are plotting pressure against volume. While plotting pressure against volume, an increase in the pressure will make volume to reduce, or an increase in the volume, pressure decrease. So when pressure decrease, volume increase. When volume increase, pressure decrease, and when pressure increase, volume will decrease. That is it. But the second one, pressure and volume and 1 over volume, this is the inverse of volume. So when we have the inverse of volume, pressure will increase, the inverse of volume will increase. Look at this now. When pressure increase, the inverse of volume will increase. Now look at this one, P. Now when you have, look at this everybody. When you have P1, P2, P3, then you will have V1, V2, then V3. You see, this is increasing, this is decreasing. But when you come to this one, here we are talking of the inverse of the volume. So when you have the inverse of the volume, your pressure will increase, then your volume will increase. This is what we are saying. P1, P2, P3. Look at this. V1, V2, V3. You can see like this. So this is how it is. So when we are dealing with the inverse of volume, we are plotting pressure against the inverse of volume. Pressure will increase, volume will increase. But when you are plotting pressure against volume, inverse will increase, and increase in the pressure, the volume will decrease. Then if the volume increase, you have V1, V2, V3, then your pressure will be P1, P2, P3. I hope you understand this graph very well. If this increase, this decrease. Pressure increase, volume decrease. Volume increase, pressure decrease. That is the first line graph. But when you are plotting P against the inverse of P of volume, both will increase. So that is the graphical representation of Boyle's law. So let's take example. All right. We have gotten to practice two examples on the board. Number one, 200 centimeter cube of a gas has a pressure of 510 millimeter mercury. What will its volume be if the pressure increased to 780 millimeter mercury, assuming there is no change in temperature? So let's quickly solve them. Number one. All right, we are told that volume 200 centimeter cube, that's the volume of the gas, that's the first one. V1 equal to 200 centimeter cube, then has a pressure of 510, that's P1. The first pressure is 510 millimeter mercury. What will its volume be? V2, we don't know, it is what we want to calculate. If the pressure is increased to P2, is now increased to 780 millimeter mercury. 780 millimeter mercury. All right, let's quickly solve this question. V1, don't forget our formula is V1 P1 equal to V2 P2. So what's V1? 200. What's P1? 510. All right, before we do this, okay, this is our formula. V1 P1 equal to V2 P2, and we are looking for V2. So first, let's make V2 subject of the formula. So I thought we make V2 subject formula. Of course, you are dividing both sides by P2. So P2 can cancel P2. Your V2 will be V1 P1 over P2. So let's slot in what we have. Then you have 200 times P1 is 510 over P2 780. Yeah, by the time you multiply 200 times 510, divide your answer by 720, then the answer will give us 31 centimeter cube. Let's quickly take number 2. I hope you understand that. Look at it. We first write the formula out. V1 P1 equal to V2 P2, because we are looking for P2. Make P2 subject of the formula. So P1 can cancel P1, P2 can cancel P2. So you are left with V2 equal to V1 P1 over P2. Then let's slot in the parameters, the figures. V2 equal to 200. Anywhere you see V2, you put 200. P1, anywhere you see P1, you put this. Then P2. So we slot it in. Then by the time you multiply this by this, then divide by 780, you have 31 centimeter cube. Now let's quickly take number 2. The lowest pressure would be required to compress 35 centimeter cube. So V1 now is 350 centimeter cube of hydrogen at 700 millimeter mercury. So first pressure is 700 millimeter mercury. Then at to 300 centimeter cube, 300, that's V2, 300 centimeter cube at a constant temperature. Of course, we don't know the pressure. What is the pressure? That's what we have to calculate. What is the pressure? So the pressure we are calculating now is what? P2. So the pressure we are calculating now is P2. Okay. So as we did to this, write out our formula. We have P1 V1 equal to P2 V2. Then when we make P2 subject of formula, of course this will multiply V2 will cancel V2. Then we now have P2 now to give us P1 V1 over V2. P1 V1 over V2. So let's slot in our figures. V1 is 350. P1 is 700. Oh, sorry. Our P1 is 700. V1 350 divided by V2 300. Our answer is going to be, you multiply 700 by 350 divided by 300 is going to be 782 millimeter mercury. So that is that about that. I hope you understand. This is just the usual approach to Boyle's law.